Yes. Good morning, everyone. I'm Likit from Gitam University, and I have been working on this project called the Sudoku Solver. So, in our childhood, we might have played Sudoku, and many of us might have solved it in the very first go, and some of us might have tried very hard but didn't get through it. Now, there are people who solve Sudoku with interest, and sometimes they face difficulty in solving it. Now, in this era of technology, we see people playing Sudoku in online. So, and in online, we use the websites that are available like sudoku.com, and we sometimes face difficulty in solving Sudoku. People face it. So, to help them, this project will be useful for them. And so, basically, I have brought full of automation into my project, a bit of machine learning, so that it makes it easy for the end user, so that they could clear the Sudoku. Now, first, there are two parts in this project. The first is the input part, in which we do image processing, and we take all the digits from the Sudoku and save it in the 2D grid. And in solving and output part, the solving is basically using the backtracking algorithm. The saved 2D list that we have taken from the input is then solved, and then using the output, we can easily fill the Sudoku. So let's get into it. First, we will see what is the input. Input is basically, we'll first take the path of that image, and then these are the modules that I have been using. Pattern GUI, this is for the output one. Time for keeping a time sleep. I'll show you later in the code. Next one is the CV2 module, that is the image processing module. Pytesseract is basically scanning all the digits from the image. Then this is the regular expression, OS module, and NumPy module for creating an array of small images. So first we take the default path, because the Pytesseract module that we download from the internet will be saved in this file in this path only by default. So we take it as we've set the default path, and then we read the image. First we have to prepare the image. That is, for analyzing the digits, we need to prepare the image. So where in this, first we take the image, then resize it, and then pre-process it. In pre-processing function, we can see that first I have applied some grayscale to it, then added some blur, and then provide thresholding to it. Thresholding is basically like we just read each and every pixel of that image to get a better understanding of what the digit or what the text present in that image. After that, after pre-processing, we find all the contours. Contours is basically like selecting all the objects or the small images that are details that are present in that image. For example, if I show you this particular example, here we can see there are many birds, one tree, this mountain range. So basically what does contours do is it applies some boundary to it, and it scans all the images, like all the small details, and stores it. After that, we go check for the biggest contours. Now that was an example, but if we provide a Sudoku image, now Sudoku, the image might contain some different decorative item and different styles or different stuff available in that image, but we have to crop the Sudoku out of it. So basically, whatever image we provide, the biggest thing, the contour that will be present is a Sudoku. So using the big Sudoku contour method, we can traverse through each contour, take it area, compare it, and find the contour with the maximum area and return it back. Now after returning it, when we get the biggest contour, the biggest contour is then reordered. The biggest contour gives us two parameters. One is the corner points of that biggest contour, and second one is the area of that contour. And next, in this is like checking if there are only four corners. If not, if there are no specific corners available, then this won't work. So biggest, and we call the reorder function. Now, whenever the image processing works, while identifying the corner points, it doesn't go in a sequential order, but we need it in the sequential order. So we use the reorder utility function, where I just reorder my points. Basically, I use a small logic that if we add the points and take the maximum and the minimum, we get the last and the first point. And if we take the difference and we get the maximum and the minimum as the second and the third point. So if we try it on a paper, you will get it towards the logic. You can see the code over here. That is, if we add it, the maximum one. Adding in the sense is like we're adding the coordinate values. Like if it's 0, 0, then it will be 0. And if the last point is 420, 420, then it will be 840. So basically that will be the maximum and this will be the minimum. And this other two will be in between them. So by reordering, we reorder them in a sequential manner. After that, we just adjust into the window size that we want to see over here. If we do cv2.im, so we can see the windows. We fit the image into the small window by cropping off the Sudoku from the main image. After that, we basically split the boxes. Now we have got the image. Now I'll show you an example. Now suppose this is the image that we have got by cropping it off. After this, the image processing module will can't find all the digits. Like it can't extract all the digits directly from this image. Like it will, but they will come in a random order. But we don't want it in a random order. We want it in the index wise, like all the 81 digits in a sequential manner. So in this way, we use the split boxes one, a utility function that splits the image into 81 small images. And by doing this, we can scan each and every image, extract the value from it, and store it in a list. I hope I'm clear till now. And after that, in the image scanning process, what we do is, if we see the utility function, I take a temporary numbers list, and traverse through each and every image. Now, basically, first I create a file of that image, read the file, and destroy the file. That is, after reading, I can use it in the code, and once it is used up, it's of no use. So destroying the means if I create a file, then a lot of space would be taken up. So destroying the file would be a better option immediately after we read it. So after we read it, then after applying some thresholding to it, and later using the Pytesseract module, we could we can see this function image to string. Basically, it converts whatever the number or text that is present in that image, it stores in the digit variable. Now we check if there is any number or any number present in that image. If yes, then it will append then it will use this regular expression, that is extracting only the number. Like sometimes we may get some gibberish values with the number, but we want only the number. So it will only take the number, convert it into int format, and append it to the numbers list, the temporary numbers list. And then if there is no number present in it, then it will append 0. After that, so I hope I'm clear that after the image processing is done, if we see, I get a list. What list? A list of 81 elements consisting of all the individual numbers. So if there is a number in the first box or in the first place, it will store it. Or if there is a space, it will take it as 0. So we can use it in the later while solving. So to indicate that this is the space. So after this, it stores in a sequential manner, so it can be solved easily and later used in the output. So when after completing the input part, that is basically image processing, and then taking out the numbers from the image. Then later, I use this while function just to create a 2D grid, 2D list, so that it looks clear and we could use it in the output function. I'll explain how. So this code that I have provided for image processing is an inbuilt module, and it gives an accuracy of 95%. That is, machine learning is a very vast and diverse subject. And for any machine to identify a text or extract any text or number, it has to be uh, trained well enough with different kind of fonts, text, different kind of images, different sizes. Only then it will achieve a greater accuracy. And with inbuilt module, it's not easy to get all the numbers. I hope you are clear with it. Like it's an inbuilt module. It's not trained for only solving the Sudoku. Like it's trained for only till a certain level. And the project that I have made in this only works on www.sudoku.com because image processing can't be done on all different kind of websites. All have different fonts, different text styles, and for that we have to teach the system. So if you see here, after image processing, I get all the numbers and then I convert it into a 2D grid. After that, I use the bug function. What is a bug function? So what basically happens is that sometimes there might be an error by the input function where it fails to identify a certain number. So using this bug function, I could manually enter the number and the location so that it could correct the grid. Like, oh, since I said it has a 95%, approximately 95 to a very high accuracy of identifying the images. So it's only few numbers have to be, manually edited. Like for example, this code fails to identify the number 9. So in that case, you have to manually enter. After that, we use a backtracking algorithm. That is, first we put one number. Let me show you. Now, suppose backtracking algorithm is nothing but if there is a 0, it tries to put one number, like suppose 1. Okay. So it checks it. First, it puts one number from one by one it puts. So first it puts 1. Yes, if it's, then it checks it. If the number is present. Now we know that while solving a Sudoku, whenever we try to put a number in a particular box, it should unique means it should not be present in that the same row or in the same column or in that 3 by 3 grid, the small grid that is present in this 3 by 3 grid. If suppose I want to put 1 over here, then it should not be present in this first row or in the second column or in this first 3 by 3 grid. So we have to check that condition. If it satisfies, then we put that number and move on to the next place. Now you might think that this is so easy that it will just put on and go, but it's not like that. At one point, now it might be wrong, but at one point there it will not satisfy that no numbers could we could enter no numbers into it. Then it would backtrack to the first position and again try 2. Then it continuously moves on until it solves completely. So in this way, we solve the Sudoku by backtracking algorithm. Now comes the amazing part, the output part. Let me give you a demo first. After that, I'll explain you how this output works. So as I said, just a second. Mm, just- as I said, this code works very well in Sudoku.com because image processing is trained only for this kind of grid. If we change the font or the contour or the color or the size, then it faces difficulty because it's an inbuilt module and there might be many errors. So I'll show a demo of it, how things work in this. So basically, we can't do web scraping over here to take out the digits from that image because after every time you refresh, you get a new Sudoku. So the details can't be stored in the inspect option. So suppose I took the evil level, you can see the time. I just saved the image. I saved the image directly into my project file and I save it as download and replace my code file. So it's saved. I hope it's visible. Yeah, you can see here. You can see here. the image. Yes. Okay. I hope that's visible. Now I run the terminal. Now you can see that first it gives me a grid, whatever the numbers it has scanned, and it will show me that grid in which it has scanned all the numbers. Yep. You can see here, and you can check the accuracy. Like you can check each row. Like first row, if you see wherever there are spaces, it has taken 0, and wherever the number, it has taken 7. So the image processing works very well. So even in the second row, third row, fourth row, and in the fifth row, as I said, it fails to identify the digit 9. So in this case, you have to manually enter the number. So the utility function comes into play. Do you want to enter 9 row number? So it's like the fifth row and the fourth column. So just fifth, 5, 4. No need to enter column. After that, you can see the sixth row is fine. In the seventh row, again, you have this difficulty where it fails to identify 9. So again, you can add yes, enter the number 9. In the seventh row, sixth column. I hope I clear. Okay. And you can check the last 2 rows, it's also correct. So you can see out of 81 small image, it identifies all the 79 images correctly, and only it fails at in the case of 9. So you can see how accurate it is. And then I'll say, no, I don't want to enter. Now the corrected grid. Corrected grid is basically solving the Sudoku, and this is a solved Sudoku that I got. This is the whole solved Sudoku. Now let me show you the output part. Now it will say, are you ready? Yes, I'm ready. Just click enter and put your cursor over this first block and just raise it. You can see it's automatically entering the Sudoku directly into the website. Like it's fully automated. You just need to sit and watch, and you have to just click it. In few clicks, you can just solve the whole Sudoku. Yep, there's the solved Sudoku, evil level Sudoku in 3 minutes. Now let me explain how did this output function work, right? So it's like a kind of magic. I'll explain it to you. It's very simple. I have used the Pytesseract GUI module, which basically controls your keyboard keys. Now, if you see that if I click a new game, let me explain how it works. So basically, what is you can fill the Sudoku using your keyboard also. Like if you click on right cursor, then you can move across the Sudoku. Like you can use this cursor to move across the Sudoku and enter the number you want. So basically 4, and just click it. So using the keyboard also, you can fill the Sudoku. So I used it, and I just use that small hint, and using the Pytesseract GUI model, I fill the whole Sudoku. What happens here is first, this is a final string, a list which will contain all the 81 digits, of the solved Sudoku. As you can see here in the output function, we got all the 81 digits in the grid. Now, from the grid, we will take all the values into this final string in the string format. The string format is necessary, and I'll explain you why. So here first we'll get ready, then we'll click ready, and after that I have kept a time sleep of 10 seconds. That is so that you get some time just to click on the first block of that Sudoku. So in 10 seconds, it will start working. And after that, using this for loop, what basically I do is this pg.press basically presses the number. Now string.num is basically traversing through all the 81 numbers. Like it first checks for the first number. What is the first number present? It is 5. So it will press number 5 in my keyboard. And since I have kept it on the first place of that Sudoku, so it will click 5 over there, wherever the cursor is pointing. I have pointed my cursor to the first block, and I'm using the keyboard to move again back into the whole Sudoku. Now this press function presses the number, and it has to be entered in the string format. Now I hope you are clear why I converted all the digits into string, because the press function clicks the number and it has to be entered in the string format. And next hotkey is basically moving you to the right cursor. Right means the cursors using this right. You can see this right one cursor to move the cursor to the right, and again press the number again. And after it reaches the end of that column or end of that row, sorry, it moves down, get back to the first place, that is moving down and then coming back to the first place, and starting from the for the second row. Basically, I'll show you here. Just observe the blue cursor, a blue mark. I first fill, reach to the end of the row, then move down and go 9 times back. So basically, here I get back the cursor to the first element of the second row, and then again I press the elements, and then slowly I fill it, and coming back to the first place again, slowly filling it. In this way, I fill the whole Sudoku. I hope this was very interesting, and this in this way I have brought a bit of automation and also machine learning into this project. I hope you loved it. So thank you for watching.